Hey there, and welcome to today's webinar, Beyond Prototypes, where I'll talk about building real-world applications with AWS Solutions Constructs. My name is Ryan Hayes. I'm a solutions developer here at AWS, and in today's webinar, I'm going to show you how you can harness the power of Solutions Constructs to build complex, real-world applications faster and better. If you're a developer who already has some experience working with these tools and who's looking to take their development experience to the next level, then you've definitely come to the right place. If you're not yet familiar with Solutions Constructs or the CDK, I invite you to enjoy today's webinar and see what's possible with this great tool set. I'll also provide some links and resources at the end for you to take away and learn more with afterwards. We have a lot of great stuff to cover today though, so let's go ahead and dive in. For today's webinar, I'd like to go over a few quick items so that you know how to participate in the event if you'd like. First, you'll be muted by default if you join today's webinar using your computer audio. Second, you'll have the opportunity to submit text questions to us by typing your questions into the questions pane of the control panel. You can send in questions at any time throughout the presentation, and we'll collect them up and address them towards the end of today's session during the Q&A. Now that we're all squared away on technical items, let's talk about Solutions Constructs. For a quick refresh, AWS Solutions Constructs is an open source extension of the AWS Cloud Development Kit. There are over 40 solutions constructs in the library to date, and we can think of these best as multi-service architecture patterns. These architecture patterns are modeled after commonly used pairings of AWS services. As you can see in the diagram on the right, the AWS Lambda DynamoDB Solutions Construct is made up of two CDK constructs, one that creates a Lambda function, and another one that creates a DynamoDB table. By adding one of these solutions constructs to your project, you get both the Lambda function and the DynamoDB table pre-configured and ready to use. You also get any secondary resources, such as permissions or anything else needed for the pattern to work out of the box. This saves a lot of time over configuring each individual resource, especially if they appear multiple times in your project. Now, as I mentioned before, each solutions construct comes pre-configured with best practice defaults to help you get started right away. However, it's important to note that they're also fully customizable and that you can fine-tune each solutions construct and its underlying resources. You can also use solutions constructs right alongside your regular CDK constructs. And this gives you a dynamic duo to quickly model bigger pieces or repetitive areas of your architecture while also being able to fill in any gaps or make customizations. As a result, it becomes super quick and easy to spin up applications of any size or scale. Now, to give you an idea of what's possible with solutions constructs, you can use them to snap together architectures of all shapes and sizes, and to fit almost any use case. On the smaller end, they're great for building prototypes, putting together demos, making a simple app, and even just for learning and experimentation. But that's really just one end of the spectrum. You can also use solutions constructs to scale out and build bigger, more complex projects too. You can use them for building out enterprise systems, complex applications, and in full-blown production settings. I hope you brought your thinking caps because today is going to be focused on showing you the art of the possible in building big. Today, I'm going to be taking you beyond the prototype and demonstrating step-by-step building a complex, real-world use case with solutions constructs. What I'd like for you to be able to take away from today's webinar are these three things. First is being able to build out a large workload using more than just a couple solutions constructs. Second is to feel comfortable using solutions constructs and CDK constructs alongside each other. And third is being able to incorporate existing infrastructure components that you might have into your project. So what are we going to be building today? I'm glad you asked. For today's demo, I'm going to show you how to build out the backend for a restaurant management system. If you've taken a close look around your favorite restaurant before, or if you've worked in one before, you probably noticed that there's a lot of different things going on there. In many cases, you'll have servers, bartenders, runners, and bussers, and then behind the scenes, of course, is your kitchen staff, managers, and many other folks that make the operation work. Today, I'll be building out a system that helps facilitate ordering. A server will create an order, the kitchen will fulfill it, and eventually the server will close out the check. I'll also add a flair of business and admin functions for managers. We'll have these three user roles, and each of these roles will have multiple things that they'll be able to do. The first role will be for the servers. They'll need to do things like create an order or process payments to close out an order once the customers are finished. Next, I'll have a role for the kitchen staff who will receive orders from the servers and work to complete them. They'll need to view all open orders at a time to know what needs to be worked on, and they'll also need to complete an order once it's been sent out to the table. Finally, I'll have a role for managers who will have quite a few different functions. They'll be able to view all orders and their statuses, receive notifications on orders that are running behind, and finally close out the service for a day. That'll include creating reports, archiving orders, and calculating the amount of tips for each server to receive. So as you can see, we have quite a bit of ground to cover today with this use case. Let's take a step over to the architecture and explore what this system will look like. Here you see the full design of what this restaurant management system will look like by the end of today's webinar. I'll be using 19 solutions constructs to build this out, and I'll also use some CDK constructs to fill in any gaps and to show you how easy it is to work with them side by side. Now, I know this is a lot to look at up front, but fear not. I'll walk you through each part of the architecture and provide some more detail in just a second. Looking at the big picture here, though, there's a few things I'd like to point out to help get you familiar with the design. First, we start with a common table in the middle for keeping orders that all user roles and functions will work from. Next, down in the bottom left, we have all of our service staff resources. Then, down in the bottom right are going to be all of our kitchen staff resources. Now, up in the top half is going to be all of the manager resources. And then finally, shown outlined in purple, is an existing piece of infrastructure that we're going to wire up to our project. In this case, it's going to be an S3 bucket that the restaurant uses as an archive, and this new system we're building is going to plug into that and archive orders there so that the restaurant can continue to keep everything in the same place. Now that we've had the chance to dip our toes in, let's go a little deeper and take this apart before going ahead and implementing it. Starting off with the service staff, I'll first spin up a dedicated API for them to use. After that, the first thing our servers will probably need to do once a customer sits down is to create a new order. So I'll go ahead and add a Lambda function that'll create a new order in the table. Next, the servers will need to process payments and close out the check once their customers are finished. So I'll add a Lambda function for updating the status and payment attributes of a particular order in the table. And that pretty much wraps up the first part of the system for our servers and wait staff. Now let's jump on over to the kitchen staff side and flesh that out. Coming in on the right side, we have our kitchen staff resources. Just like the service staff, they'll have their own API with authentication that they can use to connect to the system. And so the first thing that they'll need to be able to do is view all the open orders that need to be worked on. For that, I'll add a Lambda function to fetch all open orders from the table and snap it into our architecture here. Next, once the kitchen finishes working on an order and sends it out, they'll need to mark that order as complete so that it's off their plate. For that, I'll add in a second Lambda function that updates the status of a particular order in the table. Those two functions are going to wrap things up on the kitchen side of the house. Now let's jump on over to the manager side. Spreading the diagram out a little bit now, towards the top we have the manager side. The first thing I'll do, just like for the servers and kitchen staff, is give them a dedicated API to connect into. Then the first thing the manager should be able to do is get a readout of all the orders and their statuses. So I'll snap in a Lambda function that retrieves all orders from the table and presents it to the manager. Next, at the end of a given day or shift, the manager will need to perform some administrative tasks to close everything out. So I'll start by adding a Lambda function that serves as a closeout trigger. Then I'll connect that function to a step functions workflow that'll execute a series of 3 different closeout tasks. The first of those tasks will be to generate a report of the day's sales from the table, and then save it to a designated reports bucket. The second task will be to calculate the tips to be given to each server based on their orders that day. This function will then send a notification to each server, providing them with a report on their earnings. Now, the third and final task for closeout will be to archive the orders table and clear it out for the next day. The orders will be saved to the archive bucket that the restaurant already has. Next, the manager will want the ability to view past service reports that are created from previous closeouts. So I'll attach a function to the API that can read in a specific report from the bucket and present it to the manager. Then I'll go ahead and hook it up to the reports bucket on the other side. Finally, our manager will want to be in the know if an order or orders are running behind. So for this, I'll create a Lambda function that queries orders that are open more than a certain amount of time ago. Then I'll set up a CloudWatch events rule that'll run the query every minute so that it has the most up-to-date set of orders running behind. After that, I'll hook the Lambda function up to an SNS topic where messages will be published to and ultimately delivered to the manager. And so that wraps up the manager role. As you can see here, we have a complex real-world business system designed and ready to go. So now it's time for that million-dollar question. How long do you think it might take to model this in code? Hours, days, weeks? I'm going to show you how to do it right here in this webinar using Solutions Constructs. Instead of spending time pulling in and configuring each resource individually and then wiring it all up, I'm going to use Solutions Constructs to accelerate my development. As a result, I'll be able to put together this architecture in a fraction of the time it would normally take with more traditional approaches. This is mainly because I won't have to spend as much time configuring individual resources or performing repetitive tasks. I'll also be able to build this confidently using the best practice defaults, which means less time spent ensuring that my architecture conforms. But with a complex architecture like this, there's always going to be some tweaks and customizations along the way. That's why I'm going to use the AWS CDK to fill in any gaps and also to help me integrate the existing resources that our restaurant might have. In this case, that'll be the pre-existing orders archive. Now, before we launch in the demo, I'd like to share a few tabs that I'll have open to help guide me through building this out. First, I'll have the documentation for AWS Solutions Constructs open. This will serve as a reference for the multi-service patterns that I'll be using to build this out. I'll also have the documentation for the AWS CDK open for referencing any additional constructs and packages. Finally, I'll have the code for today's webinar open in GitHub so that I can grab the business logic for my Lambda functions and drop it into the project. If you need a few seconds to pause and open these up, please feel free. Otherwise, I'll see you over in Cloud 9. For today's demo, I'll be using AWS Cloud 9, which is a cloud-based IDE that lets you write, run, and debug code using just a browser. Now, it already comes bootstrapped with the AWS CDK as well as the AWS SDK. Other than that, I have a blank environment here, fresh and ready to go. Now, today I'll be writing my code in TypeScript. However, Solutions Constructs is also available in Python and Java if you prefer working in those languages instead. To kick things off though, first I'll need to create an empty directory for my project to live in. Now that I have an empty project set up, I'll need to make sure my Solutions Constructs and CDK versions are matching. For this, I'll first check what the latest version of Solutions Constructs is. As you can see here, it's 1.104.0. So now I'll go ahead and install the matching version of the CDK into my environment. Now that my Solutions Constructs and CDK versions are matching, I'm now ready to start fleshing out my project. So I'm going to use the CDK init command to set up a baseline CDK project for me to build off of. Once that's all finished running, if I take a look at my project over here in the sidebar, I can see that my once empty project has now been populated with a bunch of new assets. Going through real quick, inside the bin folder is a baseline CDK app that I can build off of. We then import a stack that's located in the lib folder, and then as we can see here, we have some node modules, and then finally we have a sample test case that we can use to build future tests with. For the purposes of today's demo, I'm going to comment out the contents of this test case. Then I'm going to delete our baseline stack here so that we can start from scratch. Then finally, I'll clean up the app file under the bin folder so that we're ready to start building from scratch. So now I'm officially ready to start building. First, I'm going to take care of that existing orders bucket that we talked about in the architecture diagram. For the purposes of this demo, we're going to pretend that this is an existing bucket by creating a small stack that provisions it ahead of all the other resources. This will show us the exact same way how to work with existing resources without having to go out of the demo and spin up a bucket manually. So for this, I'm going to create a new stack file under the lib folder and name it existingresources.ts. Then I'm going to fill it in with some placeholders. As you can see here, we have a placeholder for imports, an optional custom stack props object commented out, followed by our stack itself with some public variables, and finally a constructor. I'll update the stack name to existing resources. Then down in the constructor, I'm going to get ready to add the existing orders bucket. For this, I'll need an S3 bucket, so I'll hop over to the CDK documentation and find the section for S3. I'll then copy the package name from the TypeScript field here and head back to Cloud9 to install it into my project. We'll also need to specify the same version number that we settled on earlier in the project. Once that's installed, I'll go ahead and add an import statement for it up top in my stack file. Now, since I'll want to be able to use this in other parts of my project, I'll create a public variable for my archive bucket. Then, heading down into the constructor, I'll set my public variable to a new instance of an S3 bucket. And that's about it. So now that we have our existing resources stack fleshed out, I'll do a little bit of cleanup. And then I'll head over to the app file under the bin folder and import it here. So now that I've got my existing resources stack all set up in my application, let's jump back to the architecture diagram and tackle what's next. Checking off the existing archive bucket here, it's now time to move on to setting up the central orders table. I'll put this, as well as any configuration for it, into its own stack that can be shared across our 3 user stacks downstream. Heading back over to Cloud9, I'll create a new stack file under the lib folder called sharedstack.ts. Then I'll add in the stack placeholder to start fleshing it out. I'll start by updating the stack name here to shared stack. Now, since this stack is going to contain our orders table, we're going to need to install the DynamoDB CDK package to set it up. So I'll jump over to the CDK docs and find the DynamoDB package. And then I'll copy the package name so that I can install it in Cloud9. Once it's installed, I'll go ahead and add an import statement for it at the top of my stack file. And since we'll be exporting and using this table in other parts of our application, we're going to want to open up a public variable so that we can share it with those parts. Now it's time to set up the database. For this, I'll set my public variable to a new instance of a DynamoDB table. Then I'll set up a partition key. As well as the billing mode. And finally, I'll set a removal policy. And just like that, our database is now set up. Before we go ahead and add this into the main project, I'll configure a couple of other things first. One of those things is going to be to add auto scaling for our database. For For this particular instance, we'll auto-scale the read capacity so that during times of high traffic, we don't run into any throttling issues. For this, I'll set a target utilization of 50% for plenty of headroom. The last thing I'm going to do for our table here is add a global secondary index to help with some of our query operations. Last but not least, I'm going to create a Lambda layer, which will hold common database access functions for other functions to use. So first what I'll need to do is jump over to the CDK docs and find the Lambda package. And just as we did before, I'll go ahead and copy the package name from the TypeScript field and bring it back to Cloud9 so I can install it in my stack. Now up at the top of my stack file, I'll add an import statement for the AWS Lambda package. Since I want this layer to be accessible by other functions in my project, I'll create another public variable for it. And we'll set it to lambda.layer version. Now scrolling down into the constructor, I'm ready to go ahead and add it in. So as you'll notice, I marked the Lambda source code as to do. And that's because I'm going to drag in a Lambda folder into my lib folder, which will contain the business logic for this Lambda layer, as well as all of the other Lambda functions that we'll be creating. As you can see here, inside that folder are additional folders for each of the user functions. For here, we'll be using the code inside the layer folder. And so that finishes up our Lambda layer here. As we scroll up, we have a complete stack featuring a database and a Lambda layer that provides access to common functions. I'll go ahead and clean up this extra stack props object, and then we'll head over to the CDK app to get this set up in our main project. And just like that, our shared stack is all finished and ready to go. Heading back to the architecture diagram now, we'll check off our table here and then move on to the service staff resources. For this part of our system, we're going to build it in almost backwards to how we took a look at it earlier. We'll start with the Lambda functions and hooking them up to the table before setting up the API. The functionality will of course remain the same though, so the first thing we'll need to do is set up a new stack file over in Cloud9. Under the lib folder, we'll name the stack service staff stack.ts, and then we'll go ahead and copy in the placeholder. Next, I'll update the stack name here to service staff stack. And now the first thing we'll need to do here is be able to take in the database object from the shared stack so that I can hook it up to our resources. So I'm going to import the DynamoDB CDK package into my stack here. Then I'm going to go ahead and uncomment the custom stack props object and add a DB property in to pass in the database. Then down in the constructor, I'll start to add some sections for what we'll cover in this stack. First, we'll create a Lambda function that adds a new order to the database. Then we'll create a Lambda function that closes out an order in the database. Next, we'll set up an API for the service staff to use. Then we'll add a resource for each function to the API. And then finally, we'll add authorizers to our API. For the first item, I can use the AWS Lambda DynamoDB Solutions Construct to create a function and hook it up to my existing table. So I'll go over to the docs page for that and grab the necessary info. I'll go ahead and copy the package name and then take it back over to Cloud9 where I'll install it into my project. Next, I'll add an import statement for AWS Lambda DynamoDB as well as for the AWS Lambda CDK package. Then I'll scroll down to my constructor and create a new instance of Lambda to DynamoDB for my create order function. For the source code, it'll be located inside the Lambda service staff directory under create order. Next, we'll use the existing table object property to bring in our database from the properties. And just like that, our create order function is now finished and hooked up to our orders table. Now we can go back to the architecture diagram and then move on to the process payment function. Heading back to Cloud9, we can also use the AWS Lambda DynamoDB Solutions Construct for the process payment function. Since they're both very similar, we can simply copy and paste the instance and update select properties. I'll go ahead and update the code to which this Lambda function points to. In this case, instead of create order, it'll be down to the process payment folder under service staff. And just like that, we now have our two Lambda functions fully fleshed out and connected to our business logic under the Lambda folder. Now let's go back to the architecture diagram. We'll check that off and then start in on the API for the service staff. Heading back to Cloud9, we'll be using the AWS Cognito API Gateway Lambda Solutions Construct for this piece of our architecture. So I'll open it up in the AWS Solutions Constructs docs and copy the information needed to get it installed. Heading back to Cloud9, I'll install the Solutions Construct from npm. And then I'll also install the API Gateway CDK package to help out with some things around modeling our API. Now that we have these both installed, I'll scroll up to the top and add in some import statements for the two packages. Starting with the Solutions Construct, we'll get this added in. And then we'll follow it up with the API Gateway CDK package. And now we're ready to start building our API. So scrolling down to the constructor, I'll get into the third section here and set up an instance of an API using the Solutions Construct. Now that we have our API set up using the Cognito API Gateway Lambda Solutions Construct, let's go ahead and add some resources to it, one for each of our Lambda functions. Starting with the create order resource, now that I have my first resource done, I'll copy it to use as a template for writing out my second resource. So as you can see here, we have two resources now, one for each of our Lambda functions. First one is for creating a new order, and the last one is for processing a payment and closing out an order. The last thing we'll do with the API is add the set of authorizers since we have our proxy set to false. So we'll go ahead and say service staff API.add authorizers. And that wraps up our service stack. So as you can see here, we have two Lambda functions, we have an API, and then we have resources and authorizers attached to it. I'll go ahead and just look over, clean up any public variables, and then we can go ahead and revisit the application file under bin and get this imported and declared. Now, for the props in this stack, remember I created a DB prop for our database, so I'll pass that in from the shared resources stack here. Easy enough, we now have the database coming into our stack here, and we're now all set up for this part of our architecture. We can now go back to our architecture diagram, check off the API here, and see what's next, looking over at the kitchen staff. For this side of our architecture, as you can see, it's identical to the service staff side. We have two Lambda functions, an API endpoint, and a Cognito user pool to which the staff accesses the system. So for this part of our architecture, we'll go back over to Cloud9 and create a separate stack under the lib folder. We'll go ahead and call it kitchen staff stack.ts. And instead of copying in the placeholder that I've been using, I'm actually going to use the stack that I created for my service staff as a template here. This is because the two stacks are structurally identical. All we'll need to do is update some names and properties for the resources in there. Scrolling up to the top now, I'm going to go ahead and keep the same set of imports that I used for the service staff. I'm also going to hold on to the custom stack props object where I read in the database from my shared resource. The first order of business here is to update my stack name to kitchen staff stack. Then I'm going to go through and comment out the resources that I have in this template so that I can create new ones based off of them. Going over to my architecture diagram now, the first item I'll work on for my kitchen staff is the function that gets all open orders from the table. So I'll head back over to Cloud9 and start implementing that. For this, I'll use the AWS Lambda DynamoDB Solutions Construct to create my function and link it up to the table. I'll model it off the first code snippet that I have here. Looking at the code property, I'll update the file path to kitchenstaff/getOpenOrders, which is the folder that houses my business logic for this function. And that's a wrap on my first Lambda function for the kitchen staff. I'll clean up this section and then head back to my architecture diagram. Here, I'll check off the list open orders function and then start in on the function that marks an order as filled by the kitchen once it goes out. Heading back to Cloud9, I'll repeat the same process as I did for the first function, using the code snippet as a sample to work from. Now I have my second Lambda function implemented for the kitchen staff. I'll clean up this section now and revisit the architecture. Here, I'll check off the complete order function and focus in on the API next. Headed back to Cloud9, I'll use the code snippet here to adjust and build in my kitchen staff API. Just like for my service staff API, I'll use the AWS Cognito API Gateway Lambda pattern from the Solutions Constructs library for my kitchen staff API. For the existing Lambda object property, I'll use the first of my two Lambda functions, and then I'll keep any props specific to the API gateway the same. Now I'll clean up the old snippet here and scroll down to my resources. First, I'll set up a resource to get all open orders. Then I'll add a proxy with Lambda integration to my getOpenOrder function. Second, I'll set up a resource to mark an order as filled once it's sent out by the kitchen. I'll add a proxy here as well with Lambda integration to my complete order function. Last, under the Add Authorizers section, I'll update the method here to be called on my kitchen staff API. And so now I have my kitchen staff resources all wrapped up. I'll go over to my architecture diagram and check off the API, then head over to the main project in my bin folder to get the stack imported. Just like what I did for the service staff resources, I'll pass the shared database object in as a property here. Now that that's finished, the last piece of the puzzle here is my set of manager resources. So I'll create a new stack under the lib folder called managerstack.ts. I'll copy in the placeholder here and then go grab the same block of imports that the kitchen staff stack file uses, as this stack will use the same packages as well as some new ones. For my manager stack properties, I'm going to need to take in 3 different inputs. The first will be the orders table, which was created in the shared resources stack. The second will be the existing archive bucket for saving order history to. And the third will be the Lambda layer, which some of our functions will use for database operations. Now, as you can see here, our second property is highlighted in red. This means we'll need to import the S3 package from the AWS CDK. Looking down at the stack now, I'll update the stack name to Manager Stack. Then I'll get started with my first resource. Now, one of the things that a manager will need access to is the complete order history. So I'll start off by building a function that outputs all orders to the manager, regardless of their status. Heading back to Cloud 9, I can use the AWS Lambda DynamoDB Solutions Construct for this, and so I'll set it up within my constructor. The source code for this Lambda function will point to the Get All Orders folder under the Manager folder inside of our Lambda folder. So I'll go ahead and update the code attribute here to reflect that. The next thing I'll need to do is attach my Lambda layer to this function. So I'll add a layer property and specify the Lambda layer that's provided via the stack properties. Finally, I'll hook this Lambda function up to my orders table using the existing table object property. So that finishes up the function that gets all orders from the table. Now I'll check that off and start working on the closeout process. For this, I'll start by setting up each of the functions first and then working my way upwards towards the API trigger. The first function I'll take care of here is the create report function. This will take the day's orders and generate a report containing totals, sales figures, and other insights for the manager. Back over to Cloud 9, I'm going to also use an instance of the AWS Lambda DynamoDB Solutions Construct to build out this function and then hook it up to the orders table. Now, the source code for this function is going to be located inside the manager folder and within the create report subfolder. So I'll update the code property to point there. Then, same as before, I'll add my Lambda layer to this function using the layers property. Finally, I'll hook the function up to my orders table using the existing table object property. Now that I have my function that'll create reports from a day's orders, I'll need somewhere to save them as an output. Looking back at my architecture, the AWS Lambda S3 Solutions Construct should work here. I can use it to create and hook up an S3 bucket to my create report Lambda function. So I'll go find it in the Solutions Constructs docs and install it into my project. Then I'll go ahead and add an import statement at the top of my stack file to bring it into my project. Scrolling back down the constructor, I'll create a new instance of this Solutions construct to set up my reports bucket. Now my function is ready to collect data from the table, generate a report from it, and save it to a designated location. Next up, as part of the closeout process, the manager will need to calculate the tips for each server based on their orders for the day. I can use the AWS Lambda DynamoDB Solutions Construct once again here to collect order data from the table and calculate the amount of tips for each server. The source code for this function will be located in the Calculate Tips folder inside of the Manager folder under Lambda. So I'll update the code property here to point to that. Once again, my Lambda function here will need to use the Lambda layer. So I'll add in the layers property here and assign the layer for my properties to it. Then I'll use the existing table object property to hook it up to my database. Looking back at the architecture, this function will also need to be able to send out tip statements to servers via SMS or email. I can use the AWS Lambda SNS Solutions Construct here to hook up my function to an SNS topic to make that possible. So I'll go ahead and find it in the Solutions Constructs docs and install it into my project. Once that's done, I'll go ahead and add an import statement up at the top of my stack file. Now, I'll scroll back down into my constructor and create a new instance of this Solutions construct. For the existing Lambda object property, I'll specify my calculate tips function. This will create a new SNS topic and give my calculate tips function all of the permissions and configuration it needs to publish to the topic. Now that I have my tip calculation part of the closeout workflow completed, the last thing I need to do before wiring it all up is create a function that archives orders from the table into the existing S3 bucket. For this, I'll use the AWS Lambda DynamoDB Solutions Construct to read in all of the orders from the table into the function. I'll go ahead and add a new instance of this construct into my constructor here. For the code property and Lambda function props, I'm going to reference the code in manager/archive orders under the Lambda folder. Then I'm also going to add in the layers property here so that I can use the code in my Lambda layer one last time to retrieve all the orders from the table. Finally, I'll set the existing table object over to my central orders table. Now, my archive orders function is added in here, but it's not yet hooked up to the existing bucket that I'm trying to connect it to. To bridge the gap, I'm going to use the AWS Lambda S3 Solutions Construct. Back over in the constructor, I'll add a new instance of Lambda to S3. For the existing bucket object property, I'll provide the archive bucket. Then, for the existing Lambda object property, I'll provide my archive orders function. This will effectively connect my function with the bucket and give it all the necessary permissions and configuration to be able to save archived orders. Now that finishes the last of my 3 closeout functions for the manager role. It's time to wire them up into a sequence using AWS step functions. To do this, I'm going to need to install the step functions package from the AWS CDK and import it into my project. Then I'll also need the AWS step functions task package from the CDK. Now that I have those both installed, I'll go ahead and add import statements at the top of my stack file. Now that I have those imported, I can begin to hook together my closeout process. I'll first create a step functions task for each of my 3 functions, and then I'll create a chain to bring them all together. Now that I have my closeout workflow all chained together, it's time to wrap it up and have it triggered by a Lambda function. For this part, I can use the AWS Lambda Step Functions Solutions Construct to create a Lambda function and give it the ability to kick off my workflow. To do that, I'll go ahead and install the Solutions Construct into my project. Then I'll scroll up and add an import statement at the top of my stack. Scrolling back down to the constructor, I'll go ahead and create a new instance of Lambda to step function in my code. For my code property in the Lambda function props, I'll go ahead and point the source code to manager/closeout service. Then for my state machine props, I'll add the definition property and set it to the chain I created in the previous step. And so that closes out the closeout function for the manager. Now it's time to move on to the last API call that they'll be able to make. That call will be to get a specific report from the reports bucket that's fed by the closeout process. This is if the manager wants to retrieve a report from a past service. For this, I'll use the AWS Lambda S3 Solutions Construct to create a function that can retrieve a report from the bucket and then pass it back as a response. Since I already have that construct imported, I can scroll right down and create a new instance of it in my constructor. Inside my Lambda function props, I'll set the code to point to manager/getReport. Then for the existing bucket object property, I'll set that to my existing reports bucket. Now that I have the last of my API functions set up, it's time to set up the API itself. For this, I'll create the API, then add resources, and then finally authorizers, similar to how I did it in previous stacks. Up at the top, I'll first import the API gateway module from the CDK. Then I'll scroll down into my constructor and use the AWS Cognito API Gateway Lambda Solutions Construct to build out my API. Then I'll add a resource for each of my functions that'll be called by the API. Finally, I'll add in the authorizers for my manager API. Now I have my manager API all set up and ready to go. It's time to add in the final feature for this side of the system, the late order service. For this, I'll use the AWS Lambda DynamoDB Solutions Construct to create a function that pulls my orders table and looks for orders that are running late. Heading back over to the constructor, I'll create a new instance here and attach it to the orders table using the source code in the Lambda folder. Next, I want this function to pull the table every minute. So I'll use the AWS Events Rule Lambda Solutions Construct to attach an event rule to my function. Once I have it installed and imported, I'll scroll down to my constructor and create a new instance of the Events Rule to Lambda Solutions Construct. Now, to specify a schedule for our function to run on, I'll also need to install the events package from the AWS CDK. Scrolling up, I'll add an import statement for that before continuing. Just like that, our function will now run every minute on the orders table. The last thing it'll need to do is fire off a notification to a manager when one or more orders are running behind. For that, I'll use the AWS Lambda SNS Solutions Construct to hook up an SNS topic for my function to publish messages to. Now that my topic is all wired up and ready to send notifications, this concludes the set of manager resources for the system. I'll go ahead and bring the manager stack into my main project now. For this, I'll need to provide my three properties, one for the database, another for the archive bucket, and a third for the Lambda layer. And that concludes the implementation of my restaurant management system. From here, I can build the project and either synthesize it or deploy it into my account using the CDK. After building and locally synthesizing my project, I can see my CDK project output as a series of CloudFormation templates in the cdk.out folder. Looking through the manager stack, we only wrote about 200 lines of TypeScript, but that translated into well over 2,000 lines of CloudFormation markup. This is a huge advantage for developers who want to remove repetitive processes from their workflow and focus on building the unique features of their applications. Now, as I mentioned, you can synthesize your project locally, as I did here, or you can deploy it directly into your account using the CDK deploy command. You can also leverage any of the other tools the CDK provides with Solutions Constructs. And that's a wrap. Today, I showed you how to build a complex real-world workload using Solutions Constructs and the CDK. That workload used over 15 Solutions Constructs to offer a restaurant management system that served multiple roles and functionalities. I did it without having to spend extra amounts of precious time fine-tuning for best practice adherence. It came well architected right out of the box. And finally, we did it under 45 minutes, which is spectacular given the amount of CloudFormation code that equates to. As you saw in the demo, we typically follow the process that you see here, and I recommend keeping this workflow in mind as you go off and build on your own. The first thing we did was set up the environment. The second thing we did was create a new CDK project. This was that CDK init command that helped us set up our project folder and project files. Now, once we are all squared away with our baseline project, it's an easily repeatable process to add pieces of your architecture in. First, simply install a Solutions construct or CDK construct from npm. Then import that construct into your project using an import statement. Finally, go ahead and initialize and configure it as you need. You can repeat those three steps as many times as needed until you have your architecture fully functional and mapped out. While we covered a lot of ground and built ourselves a production-ready, well-architected system, there's of course things you could do next to make it work even better for you. Some things you could do might include adding in automated testing for your infrastructure. You could also start to build out a deployment pipeline using AWS CDK pipelines. Finally, you could build out a strategy for hooking this up to a front-end system for your servers, kitchen staff, and managers to interface with. Now, these are just a few of the many things you could do next with the project that we created today. If you're interested in seeing the code from today's demo, you can find it in the Use Cases section of our repository on GitHub. Here, you can clone the code, play around with it, and even build or deploy it into your account if you'd like. It's a great reference for going bigger with Solutions Constructs, and we recommend having a look at that and the other use cases out there. For more on AWS Solutions Constructs, head over to our Content Hub, where you'll find lots of great info, more videos, and other resources to help you learn more or dive into building. Finally, as I mentioned at the beginning of the webinar, I've put together a collection of links and resources here for you to keep handy as you build bigger with Solutions Constructs. Feel free to check them out, and I hope that they serve you well in helping to learn and build. Thanks for tuning into today's webinar. Once again, my name is Ryan Hayes. Please be sure to stick around for a couple of quick poll questions before we jump into our Q&A.